October 6, paper 4, question number 5, topic is a work power energy A levels. Okay, so mass given here 0.5 released from L. It means a particle here placed, okay, and it is released. So naturally it start this way. And you know that whenever release comes, it means the starting speed is 0. And we need to find greater speeds, common sense, it speed up, increase. Here it has a maximum speed. Slow down, I don't know what speed here, but I don't care even, okay? And I need the find back here. So I will apply a magic formula on keeping my focus L and M. So let's write magic formula. So work done by applied force, work done by friction force, kinetic energy plus potential energy at M minus kinetic energy plus potential energy at L. Okay, because ending M, starting L. This is 0, why 0? Because applied force is 0 because it's releasing. Okay, so this is means work done by applied force is 0. And second number, I think he said smooth, correct. So smooth, so friction 0, so work done by friction force also 0. So this 0, correct? Can I do one easy way for you? Can I bring this full with negative sign, bring here? Correct not? Or put the values, no issue. Put 0, put 0. What is Ke at the M? My question here. Half mv square. M is 0.5. So 0.5 Vm square. Done. Okay. What is the height at this level? 0. Why 0, sir? Bottom. Okay. What is the Ke at L? At L speed is 0. So this is 0. Minus plus minus mgh. M is 0.5, G is 10, height is 2.45. So just solve it and get answer. It comes here. So this become a, okay, let me find what quickly. So 0.45 into 10 into 2.45. It becomes 12.25. And here half times to 0.5 Vm square. Okay, this multiplied, so 12.25 into 2 and this divide. And here I got a Vm square and take the root. So let's find the 12.25 into 2.5 and it become 49 and root is 7 meter per second. Alhamdulillah, so easy. Yes or no? Let's go this one. He's asking kinetic energy at N. So let's see what happens now. Here you have two goals, two plans behind. For example, one student planned Ln, starting from L, ending N. One boy said, no sir, I want to start from Mn, so no problem. Like if you apply magic formula from Ln, one boy apply magic formula Mn, both are perfect, no problem. I apply Ln, okay. So apply formula, kinetic energy plus potential energy is equal to kinetic, work done by applied force, work done applied force, work done by friction force, kinetic energy plus potential energy at an end spot mean N minus kinetic energy plus potential energy is a start spot L. And I know both are zeros. And next time, now as you're getting experience now, next time what you will do, you will save your time. How come? You will not write full sentence. What you will do? You will can I reshape it in this full value? Bring here. I can say like this. Look the way. I can say kinetic energy plus potential energy at L is equal to M. Why? Because I know that this is 0, and both 0, so you can bring one side left side. So you can save your time. But again, it came from magic formula. Come back. So what is formula here? My target is here. This 0. Why 0, sir? Because release speed is 0 here. Okay, what is the potential energy? We have L. I think we have it. Mass M, G, H is 2.45. Okay, done. What is this here? This is my target. Pick my target. So leave it. Ke at N is my target. And what is potential energy? We know it. M, G, H is 1.2. And that's it. It means this will come here and I'll get kinetic. So kinetic energy at N is what I think you found. 6.25. So 6.25 joules, we got the answer. So easy. How come? This solve it and subtract from this, you can get answer easily. Let's talk about the last and important point. Clear? Last important point. If you look at carefully, first he's releasing the particle from where? From here, right? And now what is doing here? He is throwing the particle from N. Read again the question. he is throwing the particle from n. But look here, if I give an extra force, you know what will happen? What will happen here? If I give extra force, what will happen? It will go and fall down, right? If I give less force, it will go, maybe stop here. He said, no, give me such a force, such a velocity which you give, it must stop at L. Repeat my word. The word reach. What reach means? Last speed 0. Repeat my word. When I say reach, so right, if you give extra force, it will fall. If you give less force, it will stop here. He said, no. I want at sharp L. So when at L, speed must be 0. So magic formula clear. So target is what? The velocity as n is my question, and velocity at L is 0, and rest we know it. Apply magic formula. Again, because you will throw particle and release, so force gone. So I think magic formula will same work. But this is 0, this is 0. Can I say this term on this side? Yes, I can say. But this time n and L. So apply the formula, almost same formula. Kinetic energy plus potential energy at n is equal to kinetic energy plus potential energy at L. Okay, this is my target because he said fine. So half mv square, bn square. Okay, what is the height? We know it. M G H is 1.2. Okay, what is this one? Because my plan is to reach at a 0 on the top. So this 0. Okay, and height mgh, mg, and h is 2.45, and this is a half into 0.5 bn square, and it will go there. So let's see now what happens then. So 0.5 into 10 into 2.45, and minus 5 times to 1.2. Okay, it is coming 25 over 4, and into that 25 into 2 by 4 times to 0.5 Vn square, and take the root. So you got 5? So answer is Vn is given 5 meter per second. So least value of velocity. If you go more, it will fall. If you less, it will stop here, maybe here, maybe here. But what is my objective? My plan, it must given such a velocity, it should stop here. That is answer. Over.
You get like